All right, so this would be the last session for our simple shell series, and here we are. We want to discuss about environment variables and what they are as regards the simple shell program. So what are environment variables? Basically, they consist of strings that tell us a bit about our particular instance that we are in. You remember that this instance we are in now is the instance of our shell. So the environment variables basically consist of an array of strings that will tell us information about the particular session or instance of our shell. And to these environment variables have this format, something like variable equals to value. It follows this particular syntax. You are going to see the name of the environment variable, then it's going to have the equality symbol, the equal to sign, then it's going to have this is the assignment symbol. I said equality. This is an assignment symbol, then it's going to get assigned a value. So it follows this format without a space, though. Please take note of that. It's not something like variable equals to value. No, there should be no space there. So it is telling us that this guy and this guy, they are just, it refers to a single string. Anything without a space, you can decide to wrap them up and make it look somehow like this. This is a string. So, and I said array of strings. So basically, this guy, we have the variable equals to value, then we would have another string again of this type, variable equals to value. So an array of strings combining together, they give us our environment variables. And var happens to be the name of the variable, and value happens to be what is contained in the environment variable. And to see them, you can use functions like print env. You can use functions like env on and on. So let me try the print env and let me see what is going to print out on my screen. Prin print env. And when I do something like this, it's going to display a bunch of strings. So let's go up. In fact, let me clear just to so let me run this command. Okay, I want to scroll up now. So I have the first thing here. It says shell equals to something. So this is the variable. So an environment variable, there's an environment variable called shell, and it says it stores this value called bin/bash. It also says I have another environment variable called pwd, and it stores this value. So if you run pwd on your command line, it's going to give you a value. So that means when you run pwd, it's actually fetched the current environment variable. It fetched pwd value from the current environment variable you are in. That is why if I should cd backwards and I do pwd again, you can see it has changed, meaning that when you're actually navigating or you are doing some things on your terminal, your environment variables, they can possibly change, right? They can change. And this is actually interesting because it's going to introduce us to a very interesting concept right here when we're dealing with environment variables. So on and on, we have different environment variables, but the most important ones we would likely use, especially if you want to change directory and you're implementing that in your shell, you are going to need your pwd. And the other ones you would need again could be your old pwd, which is this guy. You would need your old pwd for you to change directory and all those functions. We have functions like chdir to change directory. You can on your own learn about those functions because we are not going to discuss about them. Another important environment variable is your path, which you are going to use often, especially when you want to run executables. You would want to look through this path string. You can see it's a single string. This is it. Path equals to everything here. Yeah, it's just a single string. So you are the one that will know how you are going to maybe tokenize this string and concatenate it with any command the user has entered. That's if you need to concatenate it. And if not, if the user has already entered the full path, then you need not to concatenate. You just leave path and let it be. So you need that. You need your old pwd and other environment variables that might be of interest too. You might likely use them too, but I'm just mentioning the important ones. You would also need home when you want to cd. For instance, if I do something like cd like this and I click on enter, right, and I do pwd, you are going to see it's going to take me to this directory. So that means when I entered cd, it actually accessed home, and it did cd home. I didn't pass in something here, but it knows where to take me to. It knows where to take me to. How did it do that? You are going to implement that in your own shell. When the user enters cd without an argument, just use your getEnv, get the value of home, and just cd, then pass in home. Basically, that's it. Then if I enter something like cd with my dash, when I do something like this, you can see it already took me back to where I was before. From this directory, I entered my home. From my home, I did cd dash, then it took me back to where I was. How was it able to know where I was initially? How did my shell know? Obviously, it is because it has access to what we call environment variables, and there's this particular environment variable that can tell you your old working directory, which is this guy. So that means as at the point I did my cd dash, my shell accessed what I have in my old pwd, and it did cd this guy for me. It did cd old pwd, and that is why I was able to come back to this place. So you can see that. Let me print env. You will see that for this particular instance of my shell, the old pwd will be different. So your environment variables, they change constantly depending on the particular instance or where you are on your shell. It changes, especially there are some ones that might not change. Things like home might not change unless the user decides to reset it manually, and some other ones might not change, but things like old pwd would always change. When you move from one directory to another, your old pwd will be manually updated every time. In fact, let me use this one, cd ... You can see, then I rerun my print env. See, my old pwd is now C16, unlike before at the top here that it was what? Shell. So if I should see the back inside my shell and I do old pwd, it's going to say my old pwd is what? Is shell. So it changes frequently and often. The same thing, your current working directory too is going to change. Right here it says I'm inside what? Inside shell. Whereas initially it did say I'm inside what? C16. You can see. So your pwd, you should be able to undo that. When the user sees this inside a particular directory, you have to be able to undo and change your pwd, and then you have to change your what? Your old pwd. And the reason why you need to keep changing your old pwd is because of this command called cd dash. Cd dash means your old pwd is different from cd with a dot. They are very different. So when the user enters cd ... you should know what to do. You just go a directory backwards, right? You know how you are going to implement that too on your own shell. So this is like an introduction to our environment variables and why you need them, because they are very important. They are very, very important. And the environment variable for this one can be different from this one. So the idea of processes we talked about too earlier. We said when you create a process, you use your fork system call to create a process. When you create a process, the newly created process is going to get a copy of the parent environment variable. That means inside, if I don't know if that's applicable, but whenever you use your execve, right? Let me see. Right here, where did we? Okay, C16. I already left this place. Oh no, what did I click on here? C16. So right here, at some point we worked on execve, right? So let me check that. Execve at some point. So we said at this point where you created a new process, where we call this fork system call, the newly created process, this condition is going to take us inside the newly created process. So if we have a condition here to print out the environment variables, it's going to give us something similar to the environment variable of the parent. That means if you write your function in such a way, this code in such a way that inside the parent process, inside our else condition, that's our parent process, right? Inside your else condition, if you print out an environment variable, and inside your child process, if you print out the environment variable, you can even compare and check how is the parent different from the child. But what I do know is that when you create a new process, it's going to get a copy of the parent's environment variables. So you can use that to in your code. So how can we get these environment variables in our code? We've already learned about the getEnv function that we already worked with during our last class. There's also a way to do that. So let me veer into a file called environ.c. Then I'm going to include my shell.h. I already have a shell.h there, so instead of me typing everything, I already have it there. So we can use our main. We have 3 prototypes for our main. We discussed that during one of our sessions. We have 3 prototypes for our main. So the first one is we using the void, int main void, something of this nature. The next one is we are using our AC and character pointer av. Then this should be an int. Then our main could take this type of prototype. Then the last one is we actually adding our environment variable, right? So if you want to access your environment variable, then you use this particular format, this way to do that. And during the second session, I did mention that environment variable, our argument vector is a not terminated array of string. You can check out the video. I mentioned that there. Then I did something funny. I tried to print out my AV. AV is not terminated, right? So after printing out AV, and I printed out something beyond AV. It was giving me shell equals to something to show us that I'm actually accessing my environment variable. So how it is stored, this guy, they are stored in should I say contiguous memory location. After the last pointer to AV has been stored, which is null, if you go a step or 2 steps forward, you are going to get your environment variable. I think we did that. I don't know if I still have the code. Let me see. It should be stored inside what? Inside arg.c. arg.c. Okay. Okay, maybe I must have deleted that, but I'm just trying to analyze the variables. Your AV and AC, they are stored like linearly. Where this one stops, then this one takes over from there. So since we already know that this guy is not terminated, so how can we loop through and print out this guy? What condition can we write? So I want feedback from the audience now. How can we print this guy out? We've already done the printing out of our argv, I mean. So I believe this should be easy peasy for us because we already know how to print this out. The same format we employed for this is the same thing we should do for this one. So those that were in the session, how can we print this out? Our env. Oh yeah, I need feedback. How can we print out our environment variables? Remember, it is not terminated. Then another way you can print it out is you using env. You can just type I did print env earlier. You can just type env. It's still going to print it out as well. You can use env or print env. Anyone is going to work just fine. Okay, I want someone to unmute. Or do you want me to call someone? You should just call someone random. Okay, Kesta says env not null. So how can we implement that? Let me call. Okay, Oluwakemi, please can you help us out here? Good evening, welcome. Please, I need you to unmute.
I just joined, so I don't know the process of what you actually explain. I just joined.
Oh, okay. Have you joined other sessions we did? Or were you able to watch the recording?
Actually, yeah, I watch on YouTube.
Okay, have you been following the series from the very first day?
Sorry, you say what?
I'm asking, I said, have you been following the
I don't.
series from the very first day?
No, 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 not really. I actually watched some YouTube this morning. So I was like, okay, fine, let me join it tonight.
Okay. For those who might not know where the videos are, let me just get the link and paste right here. We've already done sessions on this. Let me see, playlist. Um, okay.
Are you a professional?
Okay.
This is the link. So we have how many videos at the moment? The first one, second one, third one, and fourth one. It was during the second video we printed out our ArcV. So if you have watched this video, if you have idea of this ArcV, then you should know what we are doing right now. So that's the link to the full playlist. Okay. So someone says, can I believe you've joined since. Please help us out at this point.
Okay, you have to use a loop, either for loop. Okay, okay, you have to use a while loop because it's a condition if environment is not equal to null.
Okay, so how will I type that?
Okay, using a while loop, say inside it, say if
Like, should
if
I type
environment
wow or should I type if?
no
Okay.
while you open the bracket env not equal to null,
Okay. Like this.
close the bracket.
Okay.
We want to print what is inside environment, right?
Yes.
Okay. Um,
Should I use a printf?
yes, definitely we have to use a printf. Now I'm thinking of how to get, because we don't only have parts inside environment.
Is
They are
environment
also,
is environment a string?
yes, environment is a string.
What is this? Which particular prototype is this one? Or return value is this one?
The return value, it's is a character, is a pointer to character.
What's the
Yes.
difference between string and char astr? What's the difference between these two data types in C? If I have a character pointer and this one, what does it mean? Have
Okay.
you ever seen it before?
This one, the first one is a pointer to character, while the second one is an array of character.
Okay. Okay. If we are saying array of characters, do you know what arrays mean? Array means
Arrays means
what?
you store strings, not only one.
No,
But the first one is that you
array
store like one.
array is basically like a group of something. So if you say array of
Yes.
characters, it means groups of characters. And what is a character? A character is something like A, B, C, right? So if you group them together,
Yes.
it will give you something like A, B, C. Then you now wrap it in double quotes like this. Then at this point, this is an array of characters. This guy ABC is an array of characters. And in C, what do we call ABC? Will you call ABC a
String.
string or a character?
ABC in this case should be a string.
Exactly. So a string is an array of what? Of characters. Basically, that's what a string is. And this is how to declare a string. And how will you know? You are saying a character here and you are saying a pointer to a character. And you already know that a string is a character pointer. This is how you declare a string. So you're not saying a pointer to a character. which will give us a what? A string. Another way to do this is just declaring it as an array. You can say something like char, then maybe str, then you do something like this. Maybe this is actually confusing. This particular prototype I wrote here, maybe it's confusing. That's why it's like this. But this line 12 is actually something else. You know, a character pointer, or maybe we do it like this. View a pointer as an array. So this is a character what? Array, right? We can view a pointer as
Yes.
an array. So this is a character what? Array. But this one now, this is a character pointer, which is a what? A string. We now have another pointer again. It will now translate to an array of strings.
Yes.
You get the gist? So this one is an array
Yes.
of strings, but this one is just an array of characters. And an array of characters will give us a single string. But an array of strings will give us multiple strings combined. Like you can have something like this is the first string called ABC. You can have another one called, let's say, DEF, on and on like that. And it will now be terminated with no. But a character pointer will be something of this nature. A, B, C, on and on like that. It should just be single characters. And if you want to print them out, then this one will be terminated with a what? A null byte. A null byte. Something like this. An array of strings, you terminate them. An array of characters, I mean, you terminate them with a null byte. But an array of strings, then you have to terminate it with the null keyword, basically. So now we said our environment variable is an array of strings, which is true because if you check it and you try to print it out, you are going to see that it consists of strings. This guy is the what? Is the first string. This is another string. You can see they are together. It's not an array of character. If it's an array of character, that means everything, there will not be, we won't have a new line here, because at this point we have a new line. At this point it's probably not a string. This is the first string, this is the second string, this is the third string. So it's an array of strings together, right? The first string, the second, on and on like that. And you can even, okay, yeah, let's print it out, then we'll maybe understand better. So the question now is, since we know it's an array of strings, how do we access, or how can we print it out? Because you should know printf with a %s will likely not work for this guy, because this guy is not a string, it is an array of strings.
Or
Yes?
can we use for loop? Let me try with a for loop.
No, we can still use our while loop. We can use our while loop, we can use our for loop, anyone. But a while loop will be better in this instance.
Okay. Can I just say use okay, remove that printf. We put if environment. The second
Yeah.
okay. If open bracket env
Okay.
that's block bracket 0
Okay.
is not equal to null. Close the bracket. Now inside the if bracket we can now say printf, open the bracket, %s yes, the env. Yeah.
env.
Yes, env block bracket 0. Then go out of the if state, if background. Then okay, now we have to loop it.
Okay, you know what? Let's let me show you something.
The increment.
Let's just print out our env index of 0. Let's just print it out. I think let us print it out and let us see if it is working. Environ index of crb, gcc environ. Okay, I'm not in the correct directory. I should cd into 616, so the file should be here. So gcc environ index of c minus o. Do I have e? I have, okay, let's say en dot slash en. You can see it's printed out the first one, which is the first string. So if I want to print out index of 1, obviously I'm going to have my printf and print it out, right? Even without the if condition, ordinary printf is going to work.
Yes.
And let's say I want to print out, let's even say I want to print out index of 15. Let's just say I want to print that out. I wouldn't know what's at an index of 15, but let me just try to print that out. It's going to get it false. So if I check my environment variables, this particular guy is at an index of 15. If you check it out, if you count it, each of the strings one by one, this would be 1, 2, no, this is 1, 2, 3, 4, 5, 6, 7. I think this is 8. Then this is 9. This is 10, 11, 12, 13. Then I think 14, 15. Okay, it says this is 15, SDG. It says that is 15, and which is what we have here. So you can see that we can use our loop to loop through each of these strings. This guy is a string. env index or something is a string, but env itself is not a string. Env itself is an array of strings. So we can use what can potentially be null. It is the last index that will be null, which is after this guy, the last index will be null. So we can write a while loop to loop through from an index of what? From an index of 0. You get? We start looping from an index of 0. We now say if the last index is null, just stop. So that is what we should do. So let us do that. We still want to use our while loop. So how can we now modify our code in such a way that if the last index happens to be 0, now you already know you can print out each of the environment variables using their particular index. Now you want to write your while loop in such a way that it's going to check if the last index is 0. env itself can never be null, because env, don't let me say it can never be null, but env is not a string, so it's a string that can be null, right? So your env, maybe it can be null, but then is the individual strings in it that can be null. We are not, our env cannot be null because it always contain some values, so it can't be null. So this condition now will just give us an infinite loop, because this condition will never be true. And when we are dealing with infinite loops, we just crash our terminal. So how can we write this condition? The other person that says she doesn't understand what we are doing, I believe you know what we are doing now. Sorry.
Yes, can I continue?
You may declare an
That's
integer variable.
Welcome. I believe you are following now, because you said you did not understand what we were doing the other time.
Yes. Thank you.
Okay, so can I continue now?
Yes, you can go on.
Okay, you can initialize a variable. Maybe we can use a.
Okay.
Okay, declare a variable and initialize it at 0 to it.
Okay.
And then replace where we have that bracket 0, replace it with a.
Yeah.
Yes. And also the second one.
Okay.
We can also remove the second printf. Then inside the while loop, not the if statement, we can now increment a plus plus. I think this should give us what we need.
Why do you think this will work? Check your while condition. Check your while condition again.
While we have environment is not equal to null, it enters, and then if our environment, that is the
Wait,
first string.
Sorry, if it's a condition,
You say
what we should check for is what will terminate this loop. This loop is going to terminate at some point. So what will terminate this loop so that it will not become an infinite loop? That is what we should check.
Okay, that is null.
Can environ be null?
No, an environment.
Can it be null?
no.
No, it cannot
So you
be
say,
null.
like you say, the environment variable, the while loop, you will say the env, then the square bracket a is not null now.
Exactly. So we have to check the particular index if it is non-null, not environ itself. It's the strings we have inside it that we are going to check if it is not null. then we would print. And for us to print, that means this our if condition is like, should I say, redundant at this point, because this guy will terminate our loop as soon as it becomes null. So there is no need for us to be checking again.
But the if statement.
Exactly. So we can just go ahead and print out. So we can take out this our if condition. Since our while loop is already like an if condition in itself, it combines if. Okay, so I should delete that.
Okay.
Then I want to implement this. So I want to do something like env index of %d equals to this. So I want to come here and pass in my a and say something like this. So I want us to see the particular index for these guys. So let me assume we have no errors from there. So let me gcc my file again. It says no error, and then it's not working. Okay, did I not save the file, or am I gccing the wrong file? This is not the correct output we want. It says while this is not equal to null, printf env %d a env index of a. So why am I not getting my printf? My printf is not working. What is happening? I want you to print out env %i, that is index of 0 is this, index of 1 is this, index of 2 is this. That's the type of output that I want. Let me save again. I just saved the file. Environ.c. Where are you? Environ.c. Which is this guy? /en. Okay, I didn't run the correct executable. I think that's the let me clear. I want to rerun. Let me increase the fonts now, and then this. So it's now printed it out with the particular index. It says env index of 0, which is this guy. So it gave us the first one, the second one, the third one, the third one, on and on like that. So this is one way you can access your environment variables. But like I said, if you are accessing it this way, that means you would need your main. And from here you can see we do not use our AC, we do not use our AV, we only use our env to get our environment variables. So depending on how you want to implement it in your shell, if you want to implement your change directory, you need this guy, and you also need your home directory, which is home. You need pwd, you need your home, and maybe some other things you might need as well. Then to implement your path, you would need your path. Where is path? Which is at an index of 19. You will need to get this guy and use that for if you want to add path to your executable file. You will need that. Another way you can get your environment variables, I believe this code is not strange to anyone. Like, are we clear? I need response. Are we clear with the particular code?
Yes.
Okay, Jeff, are we still together? Jeff, can you hear me? Okay, I think Jeff is probably sleeping. All right. So let us check our manual. There's a function called environ, right? So we check our manual for that guy. It says that what? User environment. The description is what? It's an extend keyword, character pointer environ. So an array of strings, right? And environ. Extend means should I say, it's an external, or this is a particular data type in C. It is even, should I say, it has more dominance than a global variable. A global variable is a variable that you can use, like it's not defined in any function. It's outside a function. But you see this particular keyword extend.
You're breaking.
You said this particular guy extend. It's most time when you use it in C, is when you want to share a particular variable between different source files. You are still going to appreciate this particular guy when you get to your stack and queues. There's a project called stack and queues. When you get there, you appreciate
Your guys are
extend.
hearing
Same
you.
everywhere, same everywhere.
Okay, am I breaking?
Yeah.
We
We
lost
lost
you
you.
for a while.
Oh, sorry. I didn't even know. I was actually discussing about I opened my Linux manual. I did man environ. That there's another function that can help us to print out our environment variables. So I opened that up, and it says user environments. I was not talking about this particular prototype. It says no. It's not even a function per se. It's like a data type, or should I say a variable called environ. And the environ it's an array of strings. It stores an array of strings. Then use the extend keyword for this guy. Extend keyword is, should I say, an external variable that you can use between different source files. You are going to appreciate this extend keyword. I mentioned that you're going to appreciate it better when you start your what do we call it now? When you start another project called stack and queues, you're going to appreciate it better. So if you want to access your environment variables using your environ, you are going to include your headers as required. Then you just declare this guy at the top, extend. But it's expected that you declare this guy inside your header file, but I will not include it here. I want to include it here. So you declare this guy, the prototype, character pointer environ. So this guy works exactly the way your environment variable for your main function works, right? And this guy is available. It's available everywhere. You can use it everywhere. This keyword environ. So you can, on your own, you can go through the manual and check it out. This particular variable. So we have our extend. Okay, so let me veer into the file from here. So I have environ.c as the name of the file. Oh no, extend.c. Okay, so I want to exit from here. Alright. So we said we can get our environment variables using this guy. So basically the same thing we did here with our main function, which we used to get our environ.c. We are going to rewrite this exact same thing. We are going to write it here as well. So you declare this guy at the top here. We got this particular declaration from our manual. So I'm going to write this and say int main. Then I will pass in void here. I don't need these other arguments again for this particular guy. And I'm still going to access the same thing. Then it says, so I want to return 0 here. So I'm going to declare a variable int a equals to 0, right? So I'm going to say while environ index of a. I can just say while environ index of a. It's the same thing as while it is not null. It's the same condition. So I can just print f env index of a, or let me say environ index of a, that is %d equals to %s, my new line, then environ index of a, oh no, I should do this, then a plus plus, and closing my while loop, then I have that. So it's going to print out environ. Okay, I didn't add
I
my
think
a.
for %d.
Come again.
For %d.
Okay. Thank you very much. Yeah. So I did that. So it's going to give us the exact same output. So let me exit from here and run extend.c. So gcc extern.c minus o extern ext. So compile, let me decrease that, ext, and then we have it here, the same environment variables we got using our let me compile this other one from here so we see and compare side by side the ones we got from extern and the one we got from our env for our main function. So ./env, right? Or what's the name for the other one? Okay, en. Okay, this one is en. So let me compile. This is the one for our main. This is the one we got from our main, right? And this is the one we got from the extern variable called environ. So you can see, you can compare side by side and see if it's actually the same output. You can see at an index of 8 is SSH connection. At an index of 8 here is what? SSH connection. So it's basically the same thing. Both of these guys, they are accessing the same thing. You can either use your main function to get your environment variables, or you can use the environ keyword to get your environment variables. And environ is not terminated. The same thing with this guy. It's also what? It's also not terminated. That is the environment variable inside your main function. So that basically summarizes the two ways you can print out your environment variables using the third argument to your main, or you can use the environ keyword to do that. So do we have questions as regards this? Okay, I believe there are no questions. So let's just have a brief analysis of what we've been discussing so far. So I want us to just write a very basic program by combining most of all what we've learned and write our own shell, like a very, very basic one. Even if it's only execute command like /bin/ls, just a command as simple as this, just to show us how we can think and write our own program. So I'm trying to look at, okay, let me vi into shell.c. I don't think I have a file of this name. Yeah, so I can let me see, what should I do? Let me move all these files. Let me create a new directory and say make new directory and call it wait, what do I have inside test? Okay, let me remove everything I have there. Okay, I just deleted that guy. So let me make a directory and name it move, or let me just say store. So let me move everything I have here, all C files, and move it inside store. So let's see. Okay, so these are the executables I have. So let me move all these files as well. Move all files inside. Okay, let me move everything inside store. Okay, I have store itself here. Yeah, it can't move store. So let me see the inside store and let me bring out what I need. So let me move my readme into the previous directory. So let me also move my, what do I need? I need my shell.h. So I'll move that into my previous directory. Yeah, I think those are the two things I need. So let me see the back to where okay, so now let us go on. So I want to vi into a file called shell.h. Into shell.c, sorry. So now let us start with what we've been discussing so far. The first thing we want to do is to get command from the user. That is, we have to use our getline, right? So let me include the necessary header. For your own project, you might want to have a lot of files, but here we might just be doing everything in a single file. But you would want to like break it down, have a lot of functions. Maybe it's a function that will even do your getline for you. It's another function that will tokenize for you. It's another function that will do your start, because you should not have more than 14 lines in a particular function. And if you have a main function and you're having a lot of lines there, then you're going to get Betty errors. Now, one thing I would always encourage, all of your checks, right? They are being done, or no, not all, most of your checks, they are being done in the non-interactive mode. So you would want to actually have, I think there is a function that is used for that. I think it's SATI function. So you can just check. I don't know if this is the correct spelling for the particular function. Is it a single S? Okay, yes, a single S with a double T. It says it tests whether a file descriptor refers to a terminal. So most of your checks are being done in the non-interactive mode, and you'd want to use this guy, your isati function, then you pass in your file descriptor. Your file descriptor could be a terminal or not. It could be your standard input. Yeah, you likely want to pass in your standard input here, right, for your file descriptor to check if you are in the interactive mode or non-interactive mode. So please, I want you to work on this while you are like doing your own, writing your own shell. You'd want to check that out. So now the first thing you want to do is maybe to print a prompt, and this prompt you need to print it only in the interactive mode. In the non-interactive mode, please don't have a prompt there. That is, if isati happens to be false, then you don't need to print a prompt there. So the first thing you can do is even maybe in your main program you can have a maybe two programs. You can say this one is void interactive, and the other one it could be something like this, and the other one is void non interactive. So you can check if isati, then you'd want to pass in your, for your terminal, what's the file descriptor for a terminal? Are we using the numbers, or we are using standard input file number? Let's see. What are we using at this point for our terminal? Or we are passing in, okay, it says that it returns 1. Okay, can someone help me out here? Are we using our standard input file number, or we are using our or we are using the number, our 1, our 0, and our 2? Are we following? Do we understand what we are trying to do here? Trying to check if we are in the interactive mode or non-interactive mode.
I really don't understand.
Okay. Okay. But basically, when you are calling isati, let me use the one I'm sure of. Let me use my standard input file number. I'm sure you might be able to pass in the other standard in. When we're doing file IO, we discussed these guys, right? So you might want to check. This isati, like we said, is going to return. It's just checking if you're in the interactive mode or non-interactive mode. So it says if isati is true, it tests whether a file descriptor is an open file descriptor referring to a terminal. So it's going to take in a file descriptor. Why is this not typing? If isati then we want to call our interactive function, and if not, no, then else, then our non-interactive. So like we're having two functions. The first thing you want to check for when you are writing your own shell program is if you are, so this is a function, so it will be this. Okay, if this, then else that. So this is our main function, Then you might want to have a return 0 here. So let's try this out. Let's try it out. So let me come down here and define my void interactive. Now what is it actually returning? It says it returns 1 if it's an open file descriptor referring to a terminal. So if I'm in a terminal, right, it's going to return 1. So I'm going to check if this is actually equals to 1. So if it is equal to 1, then it's going to call my interactive function. But if it is not equal to 1, it's not how would I put it? It's going to trigger this guy. So that's basically what I'm trying to check there. So I can come here and define my interactive function and say something like print if I am in interactive mode. That's basically that. It returns nothing, so I don't need any other thing. So I can come here and define my void non underscore interactive void as well, and come here and say printf I am in non-interactive mode. Yeah, something like this. This is not what will be inside. I'm just using this as like an illustration. But you know, your interactive mode is going to have your getline, your string talk, and everything you want to do. It's going to have a lot of functions inside it. Basically, this is our main function. Just checking. Let's just check. So I want to include the prototype in my shell.h now, so I will not get errors. So I want to say if not defined. I think that should be if ndef, right? Hash define if not def shell underscore h. I can have something like this. This is just me setting the double inclusion, so it will not add these headers multiple times. So if not defined, hash define shell underscore h, then I can come down here and say and if, right? I believe we are familiar with what I just typed here. We've been doing this a lot of times in our C program. So if ndef this, then hash define this, then here I want to include my prototype, so I'll say void interactive, then void non-interactive. So I believe that's correct. So it says, what is it saying? WQ. Okay, so I have this file here now. Let me save this file. I just want to show you something. I want to gcc my file called what? Shell.c, right? That's the only file I'm having here. Shell.c -o hsh. It says that what? Implicit declaration of function is sati. Okay, let me mind the sati again. Where is it defined? Uni std.h, vi shell.h, uni std. I have it here now. This is it. Did I have a typo there?
Is a typo error, double S.
Okay, wow, okay. Okay. Okay, I should have a single S there. TTY, okay. I think that's where the error is coming from. Thank you for that. So I want to gcc the file, all the files again. I only have a single file. I would have used gcc asterisk.c, but only have a single C file, so I don't need to do that. Or I might even do that, but then it's only compiling one file. So I want to save it inside hsh. I just wanted to look similar to what you likely work with when you are starting your own shell, so you can relate to it. So I just compiled that and I'm doing hsh, right? And then, okay, it says nothing is happening. I just compiled the file. My void interactive is actually, it should trigger this guy. I'm even expecting it to print out something, and it should do what I asked it to do. If this guy, then void interactive, else this guy. So after calling this function, it's supposed to print out something. Then why is it not printing out something? Wow. Okay. Echo, let's say I'm passing the command to it, ls, although this is not going to recognize this inside the dot slash hsh. This is how most of your commands would be compiled. The checker is going to check because this is in non-interactive mode, right? It's going to echo ls, so it's going to pass in ls to your executable file. After it must have compiled all your files. Then it's going to pass in the command to it. It's going to pipe it in, and let's do something like this. It's almost as if this function is not working. Let's see. Let me print out something here. Printf interactive mode. Okay.
Take the two
Do you
functions
have do you have
to
do you have to
the top
declare the
of the main.
prototype, the file,
You said?
the
Take the two
prototype?
functions to the top of the main, int main.
Okay, the prototypes.
Void
Yeah.
interactive, void
Okay.
non-interactive. Yeah.
Okay. All right. Thank you for that. Void interactive and void non-interactive. Okay. Something like this.
It should work now.
Okay, thank you. So let me save and let me recompile, and then hsh, printing it out, and it's still not giving us what we want.
I think main should go down. Main should be after that, after you have declared
Declare
and
this.
initialized that void interactive, then main should be below
Okay.
because it's like a test function.
Let's have these two
Paste the
guys in
prototype
another
as at the
file.
top. I think it has solved their problem.
Um,
Mr. Sam, just copy the two functions to top of the main. I think let's try it like that and see.
okay.
Main should go below the two.
Int main should come below them.
Okay. Okay.
Then we'll now remove those prototype definitions.
Alright, so we would not need these guys again since they're in our shell.h already. Um, okay, let's rerun them. Okay. It is still not printing. Then the issue should be from, let's debug. Let's see if it's our main program. Standard input, file number, void interactive. Okay, let me pass in one here. Let's see if I'm going to get an error. Okay. What about 0? Okay, the issue is not from there. Let's go on. Let me return that stdin underscore file number else this, then return 0. Okay, I feel my main should work. Okay, let me print out something then. Print
Before they return zero. Can you print something before they return zero? Let's
okay, okay. I think that makes sense.
26.
Just so we are sure if it's even entering.
Yeah.
Print f outside. Let's just print something like this. Okay, okay. Okay, it's printed I and it's printed outside. That means it's working in non-interactive. Okay, let me do the echo that I did earlier. So it's printed. Okay, I don't have a printf statement here, so let me print something here. Print f in. Okay, let me print nay. Okay, let me put a new line there. No, let me put a new line here. Outside, a new line, then high, a new line. Okay, let me recompile. In non-interactive mode, it says that what nay outside. This is non-interactive mode now, which is this guy. So the function is actually working, but it is not actually calling. Okay. Why is it not actually printing out what we have inside our functions? That is what I still don't know, because I'm expecting it
I
to.
want to suppose
You
won't
want to
it
what?
be if it is not insertive?
If
If
it
it
is,
is not,
yeah, it is going to call this function, which is what we have here. It's called this guy. Okay. The mistake is because
Okay.
I'm
We
having
are
void.
we are avoiding it. You are
Yeah,
avoiding it. Yes.
I think that's where the mistake is coming from. I should just call the function, not uh, a prototype or something like that. So let me rerun and run in non-interactive mode. Wow, okay, yeah. It says nay, which is line 23, and it says I'm in non-interactive mode and it's printed outside, which is outside any of the modes. So if I should run in the interactive mode, it says I'm inside interactive mode and it says outside. Okay, I think that's where the problem is coming from, because we pass in void keyword here and void keyword to the other function. So basically the idea I'm trying to bring out here is that you would want to check for interactive and non-interactive. That's the first thing you would want to do, and 99% of your checks are done in non-interactive mode. I see people enter my DM and be like, Samuel, I did this, I did that, but my code is giving me this output. I run, I did my /bin/ls. It's actually listing what I have in my working directory. I did my file, and they are running their file in this way, whereas the checker is running their file like using echo /bin/ls. And because they do not have this function, it's just not going to return anything. It's not going to work. Your function has to check if it's in the interactive or non-interactive mode, and because they don't have it, then, or even if it will return something, to be printing out a prompt, because normally you would want to print a prompt, but in the non-interactive mode you do not need a prompt, and a prompt will always be printed when the checker is checking their file in non-interactive mode, and they will start getting errors. Okay, you will see the check something like got expected. Your got, there will be a prompt there. The expected, there will be no prompt there, and you'll be confused that why is it not working, stuff like that. So this is what you want to normally check for. In your non-interactive mode, you do not need a prompt, but for your interactive mode you will need a prompt. But for tonight we'll be working with the interactive mode, and because that's why we use getline. For non-interactive mode you do not use getline. You use a function called read. I don't know, is it man to read or man something? Yeah, it says read. You read from a file descriptor, and in non-interactive mode you want to read from is it standard out? I'm not sure, is it standard output or something? You'd want to use your read function, and you specify the file descriptor. I think we did that when we were doing file IO projects. We learned about file descriptors, our standard inputs, our standard outputs. But your getline will read from standard inputs, but your read, you have to specify that it should read from standard outputs or from a file or any other place where it is reading from, but obviously not from your keyboard this time around, because you are passing, or should I say you are actually sending a command into it. You are piping it inside the file, so it is not from your keyboard now. It is from any other output, but definitely not from your keyboard per se. So you want to use your read function, but we didn't discuss about read, so we are not using that. So we have no business with non-interactive for now. But like I said, 99% of your checks are done in non-interactive mode, and that is why a lot of people fail the simple shell projects. They do not care to even handle interactive and non-interactive mode, even though it is clearly stated that you should handle it, but then they fail to do that. So now we have these two functions. Let me just delete that. Let us come and work with our interactive mode. This is what we'll be working with basically tonight. So what's the first thing we need to do? We need to do what? Get input from the user. So I need to declare a variable, right? I can declare a variable, say just get input, right? I can declare a variable called get input. So let's say it is null, right? So I want to call my getline now. So let's check our manual again for how getline works. No manual for that. Getline, it requires a size underscore t, so I'll need a variable s size. Do I even need to store whatever it is reading? I don't think I need that. Let me just check what's the return value for getline. Let me just check if it fails or if it's successful. It says it returns on success, it returns the number of characters read, including the limiter character, but not including the terminating number. This value can be handled, blah blah blah. On failure to return -1, basically. So let me check if it returns -1. I'm going to use my if condition. So I'm just going to say something like if getline, then I'm passing in the line pointer, which is the address of my what? My get input. Then the next thing is what? The size underscore t. So I will need a size underscore t data type. I can say n, and I'm setting it to what? To 0, because I want it to manually allocate size for me. So I need to set it to 0. So I'll pass in the address of n. Then I'm going to pass in my stream, which is my standard input. I want it to read from my keyboard. Okay, no, I shouldn't terminate that. I'm going to do my condition to check if it is equal to what? -1. So I'm calling getline here, and at the same time I am how do I put it? I'm checking if it fails. So if it fails, we have to manually do what? We have to manually free this guy. So I can free, I don't know if I use malloc inside my let me check my shell.h. Either have my standard library. Oh, come on. No such file or directory. Okay. Okay, I added that, so I can use my free function here. So I'm going to free get input, right? Then I might want to exit as well, because obviously it fails. So I can say exit underscore failure. I can say something like this. So first and foremost, I love to check my codes as I'm writing them, so as to eliminate bugs. So I have to check this if it is working. So let us print out what getline is receiving. So let us just use our printf and say value entered is blah blah blah. Value entered is this. So let us check that. Alright, I believe we are still on the same page. Are you still with me?
We are with you.
Okay, so I want to read from my keyboard, then I want to print whatever I've read here. Okay, we need a prompt actually, so let us just print out a prompt. So you might have another function to do that for you. So where should I print the prompt? So let me print the prompt here. Print f. So let's say the prompt is a dollar symbol with a space, something like this. So let me GCC my files again. Okay, I didn't terminate that, I believe. Okay. So no. Why is it not flagging me? Okay. I didn't pass in my get input. Okay, so let me recompile if I wouldn't get errors. Okay, no errors. HSH. It's printed I. Okay. It's printing this guy out. But now you can see it is blinking. It wants me to enter something. So I'm entering /bin/ls. And then it says that what value entered is this. So I can take out these guys and these guys. You can see the basic implementation of this project now. So I can take out line 39. I don't need that. And I can take out line 30. I don't need that. I can take out line 34 as well. I don't need that. Okay. Okay. So it's only getting inputs now. It's not actually doing anything. It's just getting hello. That's all. It's not actually doing anything meaningful at the moment. So let us move on. What is the next thing we should do after getting the inputs? What should we do? Anyone?
To tokenize what we've gotten.
Now something interesting is happening.
No. Before we tokenize, I think we should do. We should create a process. So
We should create what?
we should create a process using fork. I think.
We should create a process. Why do we need to create a process? Why do we need to create a process? Please, I'm asking on the call. Why do we need to create a process?
I feel the first thing we should do is to remove the null character at the end of the string from the input.
You can see I entered hello here, and then it read in hello with my space. Because when I clicked on enter is a new line. So it has a new line here. That's why this new line is here. So I need to remove that new line, because if I want to execute my command, obviously that new line is going to give me a problem. And as per creating a process, we do not need to create a process at the moment. The only time we need to create processes is when we want to terminate such a process. Like I want to call my execve, and I know execve needs something that is going to sacrifice. So I need to call execve at that point only when I'm ready to sacrifice a process. So I don't just create processes for the sake of creating them. At this point now, I don't need execve. I still need to tokenize properly. When I'm done with tokenizing, and if you want to check if it exists too, we might want to do that. But this one we are writing, it's very, very crude, so it won't be like a standard one. Then we might not even add parts here. We're not doing all those. We just tokenize. After tokenizing, then we are going to call execve straight up. And it ends there. So first and foremost, there are some other tokenization we want to do, because you might have a command like ls with a semicolon ls semicolon ls, something like this. You can see it's listed it 3 times, right? Meaning your shell tokenized using what? The semicolon. But we are not going to do this tonight. I'm just telling you that this is one of the tokenization you'd want to do. And the command could be something like ls minus l, comma ls minus l, semicolon ls minus l. So you can see it tokenized with what? With a space and a what? And a colon. So the first one is it tokenized with the colon. So the string gotten, it now tokenized the string gotten with a what? With a space. So there are like 2 things here. The first one is what? Your semicolon. After that, you are not going to tokenize with. So these are things you want to pay attention to when you're actually writing your own shell. But for this one we are writing, we are assuming there's no semicolon there. We're only tokenizing these first ones basically, and we're even assuming there are no optional arguments here, because if we want to start handling optional arguments, we start entering malloc and free, because we need to store these guys in an array of pointers. It is that array of pointers, an array of strings. So it is that array of strings you pass to execve. But for now, we would not want to enter into that at the moment. I'm still looking at how we are going to call execve self for what we've gotten. So let's see.
So, sorry, Mr. Sam, a quick one. What are the implementations we are going to do in the non-interactive mode? I think I've not studied it to that end.
The only thing I know of is that you are not going to use getline. That's like a condition. You are not going to use getline here. Here we use getline to read. You are going to use the read function. There's a function I showed you the other time. It reads from a string. So you're going to use read to read, and you're going to keep reallocating memory. That's if it reads, like you would have to malloc a space for whatever variable is storing what you are reading from, maybe a file, or when they pipe a command into your executable. So when you are reading such input, you have to check for null bytes, you have to check for new line, you have to check for end of file. That's like 3 things. Your conditional statement will be there, like things that can make it to fail. If either the end of file condition, then that will be exit success. If it is like a null byte, then you are going to stop reading at that point. Then if your read function should fail too, you have to undo that. But the biggest, should I say, a very big difference between your interactive and non-interactive is that your non-interactive mode is not going to use getline to read. But everything that is still happening inside can be the same. The same process of you tokenizing is still the same. You can still use the same string talk function depending on, the way you are writing your own share. It can still be the same string talk, and after using string talk, if you still want to start it out, you can still use the same start function you use for interactive for non-interactive, but just that you are not using getline to read. And maybe some other things too that I might not know, but I know you would not want to use getline to read here. You would want to use your read function, because that's what we are asked to use to read. And some people would use getchar to read a single character one by one. It depends on how skillful you are with the language and what you want to do. But the one we are asked to use is the read function. Or maybe you might want to use getchar to read a single character one by one from a file. You might want to do that.
Thank you.
You're welcome. So we want to tokenize now, and we need a delimiter, right? So let's even call our string talk. So we need a let's say talk. Let's just say this talk equals to this. So the string talk, what's the distance? We are calling. I don't know if we need to duplicate this guy, because we know string talk is going to actually modify this guy beyond repair. But then let us just call it. This is not the real shell. Let us pass this, and let us delimit with a new line only. That means we are not working with optional arguments for this particular one. We're only delimiting with a new line. So let me go and declare talk here. So I have talk here, and then let me print talk, because I have to be checking every line of the code. That's how I write my own code. I have to be sure, so I will not have too many codes or too many lines of codes, and then I want to know where the error is coming from. So I want to be sure token is this. Okay, so let's do this, and let us check. Wow. It says that what? So the first error is from here. Character pointer get input token equals null. It says implicit declaration of function string talk. Okay. strt okay. String talk. Okay. hash include string dot h. Okay, the other error is coming from here. I think I'm not getting how I want to initialize these two variables to null. Is that the where the problem is coming from? Okay, should I say something like pointer talk is this what I should do? Okay, I didn't put a pointer here. I think that's where the error is coming from. So dot slash hsh, then my prompt is here, so I have my bin slash ls, and it says value entered is bin. Token is what? bin. Okay, ls, token is ls. You can see what happened there, slash bin slash ls slash pwd. Now it's not even picking my hen. I tokenize. Okay. I tokenize with slash n, so it feels that anywhere it sees slash or anywhere it sees n, it's going to just tokenize it from there. So it sees slash here, but then this first one is slash. Now why did you not tokenize with the first slash? That should not even give me anything. So it sees n and then it tokenizes with n. Let me come here. Let me add the space here. I'm not so sure how to change that, because anywhere it sees n, it is actually splitting the string slash bin slash ls. Wow, still same thing. It's tokenizing with n and not a new
You can
line
use
character.
t stroke backslash t
Backslash what? Tab.
tab.
It's still going to tokenize with t, right?
No, use both the backslash tab and backslash n. I think that one will do. Use both.
Okay, now it is working with slash. Okay, this is funny. This is funny. Character pointer delim equals to first let me make it an array. Okay, backslash n, no, should be a single character, backslash n, backslash t, no, okay, so here we pass in our delim. Okay, let's tokenize again. It says multiple. Okay, I didn't specify multiple character, overflow, warning, object called blah blah blah.
STR talk, does it take more than okay.
Yeah, the problem is coming from line 6.
You may remove the null.
Null and T.
You said
If you remove the null,
No
it will
comma
be okay.
between the null and the backslash.
okay. Thank you. Let me see. That's where the error is coming from. Now it doesn't want to take in, and I don't want to use a character pointer. Okay, let me use an array of strings then. But this shouldn't be an array of strings. It should just be a single string. This shouldn't be an array of strings. My new line, backward slash t. Okay. I'm not even using the correct slash. I think that's where the problem is coming from. Okay, I'm using the other type of slash, so it's not reading it as a special. Wow, the problem is now coming from null now. Near initialization for the limb 2. Okay, let me remove null. Null is a string, not a character. none is a string. Okay. Slash bin slash ls. Wow. Okay, now I think it is working as expected. It is working as expected. So it is delimiting with, okay, let's put in a space. So delimit with a space as well. Okay. So let's run again. ls minus l. Wow, the space is not working. The first token it should give me should split it from here. It should actually split it from here, but it's still giving me the full string. ls minus l. Okay, I didn't save the file, so it's not giving me ls slash bin slash ls minus l. So let me put in slash bin slash ls, so which is this first command. So I think our string talk is working to an extent, even though very, very crude. So I can remove my print statement here, or I just comment it out. So I can comment this guy out too, since I'm sure it's working to an extent. So what do I do at this point? I've been able to get input. I've been able to tokenize just the first one that I need, without no other arguments, only the first one, which I will assume as the full part. If not, it's going to fail. It's not going to run because I'm not adding parts here, right? I'm only getting the first one. So the other person that was asking earlier, that do we use main to get the do we use our main from here? You can see at this point safe, my void interactive, I don't even have my main. My main is somewhere else. My void interactive doesn't even have access to my execve, right? I don't have access to it. But not to say you cannot you don't need to create a new function called interactive. Actually, you might just use your if condition here called if insert blah blah blah. Then inside this place, instead of you writing interactive, you can start writing everything we have here. But if you can write it in such a way that it will not be up to 40 lines, fine. It depends on how long your program is. So you might still have access to your main, but your main function, your execve, is useless here. Like, it is very useless from here, because we are not passing in arguments to our HSH. So what do we need our execve to do at this point? Because the particular command we are entering is inside here, not here. So if you want to add part to this guy now, you would have to do some work, and you would have to add part to this guy just like we did. You concatenate, you add slash to your environment variables, and you append this guy to the end of the environment variable and slash, something like that. But we are not doing that right now. So after tokenizing, we are going to assume the user has entered the full path to the command. So we just want to do what call execve for this guy. So let us check our manual again, and let us see. It says that what is executes a program referred to by what? By path name. So you might have a function, you can just say execve you can have a function called execve. Then you do what? You call that function. You go and define this function in another file. You are just going to give it this parameter, this your full token, like the full token. That's if you must have tokenized this guy multiple times. Here we only tokenized once, and we are not dealing with other arguments. But in real life, you'd want to get other arguments, right? You want to get other arguments and store them in an array of strings, and what you have to do with them. But here we are just dealing with only the first argument. So let me call my execve. I would need to my execve would need a character pointer, right? An array of strings, which is this guy. My execve would need an array of strings. So how can we do that? Here we only have a single string. So let me create an array of strings. So yeah, a character pointer array. This is equal to null, right? So I've gotten the first token. I would need to store the first token here. This first token is a string. I will store the first token as an index of 0 here. Then the index of 1, I can now pass null, just so I have an array of strings, so I can pass to my execve. I can't call execve at this point. So that's what I want to do. I'm only storing the first token. I don't want to get the other tokens, just because of our time. So now what will I do? I need to malloc space for this guy. So I will say array equals to what? Malloc. So size of character pointer, that's the size of a string, times what? Times string length of token, no, of talk. Then I might want to add +1. Let's see. So this is the character. I'm allocating memory of what? I'm allocating size of character pointer times string length of talk. Let's look at it. The size of character pointer is 8. So I'm saying 8 times, no. Size of character pointer times, it should be size of character. So if we have a size of character, that's 8, right? Times, let's say this guy is storing just 5 bytes. So if I do 8 times 5, that's like 40. So it's saying 8 times 5, that's 40. So I'm allocating a size of 40 for this guy. But I still need a place to store. Okay, my null. So let me just add +1. Does this make sense? Size of character times string length. String length is just going to give us the total length of the string, which in this case is just what? /bin/ls. So 1, 2, 3, 4, 5, 6, 7. This is 7. So I'm allocating a size of what? 7 plus 1. That is the null bytes we are going to store. 7 plus 1, that's 8, plus what? Size of character pointer, which is what? Size of character, that's 8. 8 times.
Is it going to ignore the space -l?
Yes, we are not dealing with optional arguments now. We did not call string talk the second time. We only called it once, so we are only picking the first one.
Okay.
And I want to store this because of my execve. I need to store it in an array of strings. So I need to store the first string, then I will now terminate the others, the array index of 1 with null. So that's what I'm trying to do at this point. And I need to allocate memory for this guy, so it will conveniently store whatever we have here. So let's see. I think I still need one more. 1, 2, 3. I still need one more. This thing here, but this is the first open bracket, the second one. So this is the first closing, second closing, and I'm confused with these brackets. Size of character.
It was not opened.
1. I only have 1 opening. I only have 2. So I should have 2 closing. Then this is like this, size of character pointer times string length. I think I should open 1 here. Yeah, I think something. And if it will flag me, then
After malloc, there is 1.
1, 2, 3. Closing is 1, 2, 3. I think it is balanced now, right? So let me confirm. Size of array equals to what? Percent. What do we use to print size of? Non-consigned, ba? Then I want to check the size of this guy. Size of array. You understand what I want to do here? I want to check the size of this guy if it is the same. I just allocated size for it, even though there's nothing inside at the moment. So let me print out the size of this is just me checking. Size of talk. Size of talk equals to this. Okay. So let's try and compile. Okay, I have. It says that what expected expression before car. Expected expression before car. Array is equal to malloc size of car. Okay, can you meet debug here? What's the error message? Could it perhaps be the brackets or okay. Let's say this perhaps something like this. Size of car. Okay, let's see. Wow, top. A lot of errors now. A lot of errors at this point.
After malloc, open a bracket.
Another bracket again.
Yes, after the malloc, open the bracket before size of.
Okay, that's 2 brackets then.
That's for everything.
Okay.
So, so after the string top, close the bracket. So we'll count and see if they are matched.
I should close this bracket again, like this.
The string top. Yes, after one, close the bracket. Sorry, after one.
Yeah, there's a bracket
So
there.
there will be.
Then I need to remove this
So
one.
no, malloc should, the whole of malloc should have a bracket. So let's place the cursor at the first one.
I'm trying
No,
to. This first one is not matching with anyone. Okay, I still need another one right here then.
so we should pair them. Yes,
So
we'll pair and
this
see if they
last
are.
one is matching with this. This second one is matching with this. This third one is matching with this. This fourth
We
one
don't
is
need the
matching with this.
second.
So we don't need this size of this one
After car should be closed. Size of
of
car
car.
should be closed.
Yeah.
So we
No,
remove one of the last one.
One, yeah. Second
So
one.
let's pair again and see.
Third one.
There should be two
let's
at
see.
the end.
The first one, the second one, the third one. This first one is not matching. This one. Okay, this one is matching with this one. Okay. Alright, so let us try and run again. This bracket it's still saying expected expression before my car.
Size of put the car in a bracket on its own. Let's see what will happen. So you remove the bracket before one bracket before size of and put car in a bracket.
Okay.
So let's see.
Okay, it's working now. It's working fine. So let me okay, I think I just edited that. Size of car. Let me compile. Okay. So dot slash hsh. So let's say pwd. It says that what size of array equals 8 and size of talk is 8. So it has gotten the size of these two guys, the size of this one and size of this one. So we can now go ahead and say array index of 0 equal to what? String copy no, okay, let me check string copy. I don't think string copy returns something. strcpy doesn't return. Yeah, it only takes in two arguments, destination and source. So if I want to return something, then I will need to use string duplicate or something like that. So let us use string copy. Let's use string copy. So destination first, which is what? Array index of 0. Then our source is from where? Talk. Yeah, let's do something like this. So let us confirm if it copies the value there. So let me print out array index of 0 and print out array index of 0. All these ones now in the real shell you have to use a loop, because as you are tokenizing you need to be allocating memory for each of the indexes or indices you'd want to add this string until this condition is false. Like you have to write maybe a do while loop or something like that until your string talk returns null to this guy, then it should stop. So you have to keep calling malloc every time, but we are just doing it only once. But in the real sense you have to use a loop that will keep allocating memory or size for this your array of strings before you now call your execve. So let us confirm compiled. So ls, it says segmentation fault core dumped. Therefore the error should be coming from where did we call string copy? Yeah, it should be coming somewhere from here. Somewhere from here. Let us use string duplicate. But let me see, how does string copy work? Malloc size of this guy. Yeah, it says size of array is 8, size of talk is 8. Let me change this to 2 and let's see if it will work. Length of talk plus 2. Let us see if it will work. It's still giving us a segmentation fault error. Let me see about this function. It copies this thing to the buffer. The string and the destination must be large enough. Okay, let us use string doc then.
Do we have anything inside that array index of 0?
Yeah, I think that's what we did just here. We copied this guy into it. Okay, you're looking at it as if we are trying to access a memory location not assigned to us, right? Yeah, that's what we did here. Array index of 0, copy this guy. So let me check if we can use string duplicate, if that will work. Returns a pointer to the new string, which is the duplicate of the string s. So how do we use that? String dup, it is only taking one argument. So we're going to say something like array index of 0 equals to string strdup. We want to duplicate what? Talk. Then let's try this out if it will work. Wow, let's see. Okay, string dup is working, but string talk and string copy failed. No, I did say it should print out line 25. Like, did I not save this file? Okay, this is itself. Oh, okay, it's working. Line 25, this is it. It says that array index of 0 is ls. Then it's printed out 28 and 29. Now it's saying the size is 8, blah blah blah. Okay, so I should change this guy to 1. So I can now go ahead to initialize array index of 1 to be equal to null. So I want to print out the array, so I can say int I equals to 0. So while arr index of what? High, right? So the way we printed our environment variables earlier, that's basically what I want to do here.
Okay. And while index of I is not equal to null.
Yeah, I can just say while index of I.
Okay.
Print f. Let me just copy this. So I can just print this out, index of high. Obviously, it's just going to loop only once because I'm only printing out the first value. So I plus plus. So it's going to say print f array index of %d is this. Then it's going to pass I to that place. Then this. Okay, so let's see. We duplicated this. So I can comment out line 25. I want to use this guy to do it, my line 30. And let's see if we are not going to run into an infinite loop. It's compiled. So ls, and it says array index of 0 is what? Is this. Why? Because it's accessed, that means it accessed the next element, and it knows that the next element is what? Is null. So I want to do something. I want to remove the next element as null, right? And I know it is going to fail. I will now put a condition here. If I equals to 5, then break. So I want to comment out line 26. What will happen if you decide not to set the last string in your array of strings to be null? Obviously, I want to see if this line is actually doing the work, right? If this line is actually doing what we asked it to do. So let me recompile, just so we do not run into an infinite loop. So I will just put my condition there. So it still printed out the first one. Okay, it's printed out the first one. That means this line is not actually doing what we think it is doing. And I feel the reason is because this guy is not terminated. Maybe by default it terminated it with null. Maybe, or maybe not, or because we only allocated this size for it, the size of 8. Okay. We allocated size of car here times string length of this guy. What if I decide to use size of character pointer? What will happen? That means I'm allocating the size of the string. It's still giving me the same 8. Array size is 8, string length talk plus 1. Wow.
So if I get you right, that means every array index we are using, we have to malloc it. Because I'll be writing without malloc.
Yeah, you have to allocate memory for it. If you do not allocate memory for it, you will get segmentation fault.
It's okay.
You know, you do not know the size of this string. You do not know. Let's say user entered something like this. Obviously, the size is going to increase. Wow. The size is still... Wait.
Eight.
Okay, the size for a string is always 8. Okay, I think that's why. The size for a string is always 8. But the size of this guy should change. The whole array. Like this line 36, I'm expecting it to change based on the value it is getting. But then line 36 is not changing. Size of array is not changing. Whereas I'm expecting it to change.
Can we print out string length of talk and see? Maybe around 21.
Okay. Okay. Yeah, that makes sense. Let's just print out the string length of talk and see if that value is this. strlen talk. So I want to use my %d length of talk is this here. So let us run again. Takes long unsigned. Okay. ls. It says length of talk is 23, size of array is t8, and then it is t8. It is t8.
There is no way.
Pointer. I'm typecasting that. Let's see. Okay, I think this line is not actually being in effect. Alright, let's move on. So that means our length of talk is changing, which is this guy, but size of the array still remains 8, and this one too also remains 8. Okay.
We have an error in that line 22.
Wait. Size of
Maybe the
array
way
index of 1. Let's do something like this. Okay, let me do something like this. Okay, you still give me the same 8. All right. So let us comment out these lines. We do not need them. We do not need all these printf statements. It's just to check our code and the way it behaves. So we've been able to get, so I can remove this my line. This is my condition, and this as well. So we've been able to get the command, and we're able to store it in an array of strings. So we can now go ahead now and create a process, right? So I can say for rv equals to for, and then I'll create a process from here. So I'll do the usual condition of checking if it fails and if not. So I'll just skip that for now, and I'm going to say that if for rv equals to 0, that is if I'm in the child process now. If it returns 0, then I'm not going to call my then else. Then I'm going to do what I wanted to do. Then obviously I think I'm going to wait, and I should have status here. right? So I will declare an integer call status, then let me man to my fork, then I need a PID underscore t, then status, okay, then int status, then a PID underscore t called for rv. So I've declared those two integers now. So here I would want to call my execve, and I can say if execve, and I want to pass in what's the name of my array of strings now? Array index of 0, which is the first argument, right? And I'll pass in the full string to it. Then the last one can be null. Yeah, equals to what's the return value? I think -1. If execve fails, let's see. Execve will return -1. Okay. No, this is fork return value now. Let's see. Yeah, this is fork, not execve. Man execve. What is it going to return?
-1 when it fails.
Okay, -1. All right. Okay, -1. So it takes in 3 arguments. If it is -1, then I can just print an error or something like that. Failed. But if not, the path name, which is array index of 0, then the full string, array of strings, then the environment variable, which I'm passing as null. Then after doing this, let's see. I'm now going to come to the else statement. The else statement is basically not doing anything. It's not doing anything. So yeah, let's do that. So it's going to terminate this process. Of course, we know that, right? Where did we call the fork system call? Okay, that's on line 30. Okay, so we basically have this, even though it's not doing anything so major, but let us try that out, or what we've been trying to do since. So I compile again. It says wait takes, okay, a pointer to an integer, address of wait, let me see, the recording still ongoing, almost 2 hours. Oh wow. Okay, so which other error am I having? Okay. So I want to compile again. Okay, it's working. Then this is a command that would fail. So now execve is working. It says that no such file or directory. So let me compile again and let me pass in the full path, and then it is working. By this point, it's not going to take in any arguments, of course. It's not going to take in any arguments. You can see it's only working on this one. So you have to find a way to add the other arguments to your array of strings, so that your execve will read through everything until it finds null. So this is just how we can, and then you'd want to implement your start, because we didn't use start here. Normally when we use start here, and instead of it saying no such file or directory, we have to use start, and if it is failing, then we'd have to go and add the path by ourselves, then we'll pass it again if it will still fail and all that stuff. But we aren't doing that here. So on your own, you'd want to do that. Then you want to also write your own non-interactive function, and make sure it's not printing any prompt. Okay, let me just let us run echo /bin/ls. I want to pipe it into what our executable. HSH. This is printing out in non-interactive mode. You can see it's not even doing what the command is supposed to do, whereas it can take in commands. You can see it is something else it is printing out, which is this thing. Okay, uh let's say we do not have this in our file, right? Let's say I do not have the condition to even check for interactive or non-interactive. Let's just say I called interactive in my main file simply. I want to see the type of output I'm still going to get. I will recompile everything. Wow, it is still working. It is working. And a potential bug you can see in your code is that normally for your interactive function you would want to print a prompt, right? It's going to print a prompt even though the prompt is not showing here, but then it is printing a prompt. I think this is the prompt. I feel this is the prompt. This is the prompt with a space. But in the non-interactive mode, you are not supposed to have a prompt. So no matter how many times you check your code, you can see what I'm saying. It is always going to bring out this prompt unless you remove the prompt here from your main function at this point, unless you remove your prompt. And you would likely not want to remove it because you'll be like, normally you are supposed to have a prompt in the interactive mode. So the best thing is just to create a function that is going to serve as your non-interactive mode, and there you are not going to put your prompt because the checker, I think the last check for the project is going to check for your non it's going to check in interactive mode, and you want to take note of that. Do we have any questions as regards what we've discussed so far?
Mr. Sam, can we just quickly run through the code we just ran last? That echo, I want to see how is we have to tokenize. We tokenized it. I want to see how we executed it.
Okay, I should explain it briefly.
Yes, let's just run through it. You use echo space
Okay,
bin
this one,
slash ls.
this
Yes.
this particular command is just saying echo is going to print out something now to the standard output. You do echo ls, it's just going to echo whatever you want it to echo, but then you can redirect it. This output now is our standard output. You can echo ls inside a file.
So sorry, did we run it with our own shell? The shell we just built.
Yes, I passed it in it. This is hsh.
Okay.
Maybe you
Okay.
are not seeing the full this thing. And you can even echo ls inside your bash. Okay, I have to specify bin slash bash. Okay, let me wrap it. Okay. I have to pipe it in. It's because I didn't pipe it in. I have to pipe this command. Normally echo is going to print to the standard output, but you can pass any arguments using this your pipe. This is your piping operator. You can pipe it into an executable. So I think bash self should be able to get it. Yeah, bash is my the instance of my shell, so I can pipe it into my bash. So most of your checks, this is how ls is going to check them. It's going to pipe it into your executable file. It's going to compile your C files and it's going to pipe it into the file properly. So that's why I said you need to take care of your interactive and also your non-interactive function. So the command I ran earlier was this. I piped this in and then it printed out a prompt. Why? Because in interactive mode it's going to give you a prompt normally, and when you run something like this, it's not supposed to run in interactive mode. It's supposed to run in non-interactive mode. But because I didn't have a non-interactive mode function, that is why it is running like this. And I already commented it out, and I do not have this if condition. Unlike before that I checked if it is non-interactive, it was only bringing out this guy. So that's basically it. Do we still have other people on this call, or are we still following? Okay, because there is a space there, I think that field. What did I type here? It says no such file or directory. I think I've already typed something else here. That's why it is failing. How can I recall previous this thing?
You said?